Okay, this lesson is going to focus on writing equations of absolute value equations from graphs. Now, the nice thing is that we can use several things that we've talked about from writing and graphing lines to help us. All right, so let's go ahead and review, all right, a couple of things that we should know already. Okay, one, we should know the vertex form of an absolute value equation, which is y equals a times the absolute value of the quantity x minus h plus k. Now, we call this vertex form because a, okay, represents the rate of change of our absolute value equation, and then hk is the vertex of our absolute value function. So we just need to find two pieces of information from our graph in order to write the equation of an absolute value function. The slope or rate of change, which is represented by the a value, and the vertex, which is hk. Now, right away, we should be able to know if a is positive or negative, because if the graph opens up, we know that a is a positive value, and if it opens down, we know a is a negative value. So we will already know the sign of a based on whether it opens up or down. Then we can find the actual value of a just like we find m, or our slope, for a linear function. So let's go ahead and put all this into an example and see how we do. All right, so you can see at the top here I have our vertex form laid out for us, y equals a times the absolute value of x minus h plus k. So the first thing I'm going to do is look at my absolute value equation. I'm going to find the point of the v, which is this guy right here. So this is the vertex, all right, of our absolute value function, which is 2, 2. And right away I can take this information and plug it in here. So y equals, and then x minus h, so h is the x coordinate of our vertex, so minus 2. K is the y coordinate of our vertex, so plus 2. So the only piece of information I'm missing is our value of a. Now, right away, our absolute value function opens up here, all right? So we know a is going to be positive. So now all I have to do is find the rate of change, just like, okay, we did for a line. So up 1 over 2, looking at our rise over run, up 1 over 2, and then up 1 over 2. So we can see, all right, that our a value is going to be 1 over 2. And there is our completed, all right, equation of our absolute value function. All right, let's take a look at another example. All right, so if we look at this problem, all right, once again, the first thing I want to do is identify the vertex of our absolute value graph here, which is this point here, which is negative 3, 2. So the vertex for this is negative 3, 2. Now, a little detail here. Notice the x minus right here is part of the formula. So if the x coordinate is negative, I'm going to be subtracting a negative number, so x minus negative 3, which is going to simplify to x plus 3. And then once again, plus k, so that's our y coordinate, which is plus 2. So once again, now all I have to do is find my a value. Once again, our absolute value graph opens up, so I know a is going to be positive. So I have to find some good corner points, all right, unlike the last graph, which were identified for me. And I can see my rise over run is up 1 over 1, up 1 over 1, up 1 over 1. So I can see that my a value is a positive 1. So I just plug that in. Now, if you would like, you can leave it like this, or you can just rewrite it as the absolute value of x plus 3 plus 2. So the 1 you can write, or you cannot. Either way would be acceptable. All right, one more example before I have you do some on your own. All right, so if we look at this, we can see an immediate difference compared to the prior two problems, and that is that our absolute value function opens down. All right, so before we get to how that affects our a value, let's identify the vertex, which is the point of our v graph right here. All right, so the point of that graph, all right, is negative 2, negative 1. So once again, I can immediately take this and plug it in. So y equals, once again, I'm subtracting a negative, so that's going to be x minus negative 2, which is x plus 2. And then I just take my k value, which is negative 1, and tag it on the end there. Now, right away, we know the a value is negative because our graph opens down. All right, so I can go ahead and put the sign of a in right here. Now, once again, I'm just going to take and find some good corner points here. And I'm going to find my rise over run as if it were a linear function. So I can say I go down 2 to the right 1, down 2 to the right 1, and I could keep with this pattern, all right? So I can see that my a value will be negative 2. All right, so at this time I'm going to give you a few examples, all right, starting with this one where I would want you to pause the video. I would like you to try to write the equation of this absolute value graph, all right, and then check your answer. So go ahead and pause the video and then turn it back on to find the answer. Okay, so let's take a look at the answer. All right, so you should have come up with the equation y equals 3/4, all right, times the absolute value of x minus 4 minus 5. All right, let's try another one. Okay, so now once again, go ahead and pause the video, all right, at this time, and write the equation of this absolute value graph. Okay, the answer is y equals the absolute value of x minus 3. Now, once again, a couple of small details here. Okay, so once again, our a value is 1, and our vertex was the 0.30. So some of you might have had an absolute value function that looked like this for your answer, y equals 1, absolute value of x minus 3, and then plus 0. And once again, this is completely appropriate. Just know that you probably would not see it written like this if there were a multiple choice question on an ACT or SAT or a PART test or something like that. All right, you're probably going to see it reduced like this. All right, but this would be an acceptable answer on a quiz or a test for my class. All right. Let's try a couple more. Okay, try this one. All right, go ahead and pause the video. All right, let's take a look at what you have. So once again, okay, you could have a little bit more detail here. So you could have a plus 0. All right, so some of you may have written it as 3 and then x minus 0 plus 0 like that. Once again, that's a 0 and not a 2. So once again, that would be acceptable work. Just know that if this were a multiple choice selection, all right, like maybe on your final exam, it would probably be written like this. So just make sure that you know how to find an equivalent form. All right, so let's look at one final example for this video. All right, so once again, go ahead and pause the video and attempt to write the equation of this absolute value graph. Okay, so let's look at the answer, which is y equals -2. So once again, you can see right away that the function does open down, so you should have a negative a value, and then you can see I go down 2 over 1, down 2 over 1, down 2 over 1. So my slope is, or my rate of change is -2. And then our vertex is 1, 3, so x minus 1, and then plus 3. All right, so that concludes this lesson of writing the equation of an absolute value function from a graph. All right, so once you finish this video, all right, you need to check in with me, all right, and get your worksheet unit 4.5 to complete during class. Nice work.